3 investigations for you guys based on this applet, all related to the periodic time or how long it takes for the particle to go from one extreme to the other and back to its original starting position. So I'm going to show you how I do it. I'm going to demonstrate for 10 oscillations or 10 repetitions. I'd ask you to do it for 30 to obtain a more accurate value for the periodic time. So this is going back and forward. Let's turn off the damping. This thing is going back and forward. I can turn off the velocity as well, it's a distraction. And then I'm just going to slow it down. So at the extreme, I missed it. At the extreme, press play. All right. So then we're coming to 1 oscillation, 2, 3, 4, 5, 6, 7, 8, 9, and we're waiting for it to get to 10. And I'm deliberately using the slow thing there so I can get this as accurately as possible. There we go. So then if that's the time for 10 oscillations, I divide that by 10 to get the time for 1 oscillation, which we refer to as the periodic time. I'd ask you to do that for 30 oscillations. That will give you a more accurate value. So my first question is this. With that particular oscillation, I got it to move, let's see, 40 centimeters, right? I'd be curious for you to investigate what would happen if instead of moving at 40 centimeters, you moved at 60 centimeters initially. So let's put on all the damping, we leave it come back to rest, and then we'll start it again. I'm going to pause it. So you'd pull it down to 60, the middle of it down to 60, and then you leave it go. And then I'd ask you to measure the periodic time again. And what I want to know is, if you increase the initial displacement, if you increase the amplitude in that case, is the periodic time increased, decreased, or does it stay the same? So that's number 1. Let's put on the damping again. Number 2, if you were to pull it down the 40 centimeters, because that's what we started with, and if you were to change the mass, so if you were to double the mass, let's say, there we go, double it, you can see my equilibrium position has changed, so I'm going to have to change the 40 centimeter mark there. If I pull that down to 40 centimeters, is the periodic time increased, is it decreased, or does it stay the same? So I'm asking you to do that. And then go back to 100 grams, and you're doing an investigation this time with the spring constant. So lots of damping to reset it. Damping down to 0. Let's press pause. And let's increase the spring constant. Look, we're going to have to do the damping thing again. And then in this case, if I pull it down 40 centimeters here again, and left it go, what happens to the periodic time? Does it increase, does it decrease, or does it stay the same? Okay, when you're done with that, if you want an extra extension activity, I'd like to know, is there a relationship between the mass and the periodic time? So if I double the mass, does the periodic time stay the same? Or if I double the mass, does the periodic time double? Or if I double the mass, does the periodic time half? And likewise with the spring constant. Do you think if I double the spring constant, would the periodic time double? If I double the spring constant, would the periodic time half, or would it stay the same? And if you get that done relatively quickly, and you do have some time left, I'd also wonder what happens when you double gravity. So what happens to the periodic time when you double the acceleration due to gravity? All right, you should have a bit of time there to do that, and come back then with your findings in a moment.